I don't know how you have this energy at 4:30 after sitting in a room. Anjana, I don't know how you have the energy, period. I am also incredibly excited to be here, but unfortunately, you might not be able to tell that. I suffer from this condition called being Finnish, and it's not true that Finnish people don't have emotions. It's just our face doesn't really participate in the transaction, and our sort of like tone of voice is like fairly flat. But I am actually really thrilled to be here and at JSHeroes finally after many years. And I'm also excited to be here because, I don't know, there's something really exciting happening in technology, you know, all of this AI stuff that we'll be talking about now. And I've been a web developer for almost 20 years. I'm 37 years old now. So if you do the math, that means that I've been a web developer longer than I was a human being before I was a web developer. And after you do anything for that long, you sort of like start to understand the material. You start to sort of see the brickwork behind the facade. And for me, it started to feel for many years that web development is kind of like going a little bit back and forth in circles, you know? We are rearranging rectangles in increasingly complicated ways. Then we make it too complicated, we make it simpler. But it's, you know, this sort of cycle. But now I've been really excited. I've had opportunity to work with these AI tools for a while, and I want to share something that I've learned during that time. The two questions I want you to sort of think about when you're listening to me is like, when a new technology like this comes along, how can it make the things that you built better? But also, what does it enable you to build that just wasn't possible before? For me, when I asked myself that question, one thing that I connected to is I love literature. I didn't go to school for computer science. I went to school for literature. And it's been really frustrating to me to think, like, why are we as technologists not really able to provide better tools for storytellers? You know, we have Microsoft Word, and that helps at a textual level, but there really hasn't been anything that helps writers tell stories. And I think this is fundamentally because computers have been good at some things, which is things like memory and math, which, you know, human squishy brains, at least mine, aren't really that great at. But they've been also really not good at other things, and one of the things is language. Language is this fundamentally human thing that, you know, in a way, like defines humanity. I mean, it helps us grow and learn together, that we don't have to independently figure out everything for ourselves. But we also have this innate sort of motor inside of us that sort of thrives on stories and storytelling. So what I wanted to do is explore how can, you know, these new AI models that can understand natural language, how can they help people, you know, write stories? So that's what I've been working on. My name is Jani Eva. I'm just a regular old web developer, old being the operative word here. And in the last year and a half, I've had this opportunity to work with these AI models, and I want to share a little bit what we've learned doing that. And alongside myself, I want to mention two people. I've been working with Ryan Bauman, who's a designer. He's also a literary editor. And Jeff Elmore, who's an ML researcher, but he's also an artist. And Jeff has helped me you know, design these beautiful graphics for this talk using Midjourney and other generative models. But before we get started, two notes. One, I realize that not everybody here is a writer or that mad about literature. So when you look at the things that I'm about to present, try to transpose those into the things that you care about and maybe the things that you're working on and see how they apply. I think you'll find that there's a lot of overlap. And secondarily, there will be a lot of text showing on the screens. The text might be too small if you're vision impaired. It might be also too small if you're just sitting in the back. But that's not a problem because the text isn't the point. You know, I will only use that to illustrate sort of like the UI patterns. You don't need to be able to read the individual words. And anything that you need to be aware of, I will point out and say. All right, so this is the project that we built. This is a writing application. It's a web-based writing application. But it's not just a normal writing application. It's sort of like tuned to storytelling. So I understand things like your characters, understand your story structure. It's able to provide feedback as you write using these AI models. It's able to also help you get through sort of like difficult writing moments like writer's block, or maybe describe things that, that you know, you yourself don't necessarily have the right words for. And it does a lot more, but you know, this is not a room for fiction writers, so I think we can sort of leave it at that for now. What this is though, is a room of programmers. So you know, this talk will be structured in 3 acts, like every good story really always is. First, we'll touch a little bit on AI. This is not an AI talk. I think all of us have been broadly bombarded on Twitter and other platforms about everything that's happening in this space, so we don't need to go deep, but we'll touch on it. The meat of this talk is the part 2, which is UI. How do we actually build user interfaces that help humans and machines collaborate in the space? And then finally, to get a little bit lower level nitty-gritty, we'll look at how can we actually implement these things using JavaScript. Sound good? Good? Yes. Yes. All right. So I put AI in scare quotes here because I don't actually like this term AI very much. It's a very overloaded term. There's the saying that when you're selling something, or when you're raising money, you call it AI. And when you're hiring, you call it machine learning. And then when you're doing it, it's just linear algebra. This term is very broadly overloaded, but I think we can be more specific. So what I really want to talk about today is large language models. This is a sort of like category of algorithms, of deep learning algorithms that have emerged in the last few years. The one that everybody, I'm sure, here knows about or has heard of is GPT-3, 4, and ChatGPT. But there's other models as well. Some of them are open source, like Bloom, and I think in the future we'll see a lot more open source models that you can self-host. But then most of them are actually made by very large tech corporations like Google, Microsoft, et cetera, et cetera. And this is because these models are very large, and they are very expensive to train and take a lot of know-how to do so. So for now, this is not a very democratic space. Like right now, if you're looking to, as a UI engineer, to build something, you're probably not looking to actually train your own models. At this point, you probably want to use something off the shelf. But the good news is that this is what these models are very powerful for. So not to throw like a dictionary definition at you, but so the GPT in GPT-3 stands for generative pre-trained transformer. The sort of short story of this generative, as in like it can use to generate things like text, it's a transformer architecture, which means that it takes this long legacy of language model research, and by adding this sort of like attention mechanism, it's able to actually sort of coherently both produce and understand long sequences of text, which is very useful for this task. But the key thing I want to focus on here is pre-trained. These models are fundamentally, for all effects and purposes, we can say that they contain collectively all of human knowledge. This includes most of the internet, it includes most of the published literature, which for us as writing tool has been very useful. But the information is already there. And what this actually makes it possible is that you can now achieve basically in seconds or in minutes what it would have previously done, taken thousands or millions of dollars and thousands of hours of AI training. So like these tools, while they cost money in the sort of cost sense, but they are actually incredibly easy to play with, incredibly easy to iterate on, and I highly recommend everybody to give it a shot. But, if you look at, how do these things actually work? I'm using the GPT-3 playground, which is, the sort of same, access to the same model that you would access via an API if you were building your own program. The black text here is called the prompt. This is the text that I'm sending it as basically you could imagine as an API request. And the green text would be then the response that you get, which you can then use in your application. I don't think we need to go that much more into the detail. But at very low level, what LLMs do is that they predict the next word in a sequence. And then the next word, and the next word, and the next word, and the next word. And that, sounds deceptively simple. But these systems have actually really interesting emergent qualities. So, I'm sure that there's very few people in the room who haven't yet tried ChatGPT. But, basically using this sort of like transformer model and all of the data that is fed into it, you can actually get these machines to do very, very interesting things. But how does it know how to answer questions? Does it have an agency? Is there a ghost in the machine? Yes? Now, it's an interesting fact of human language that a question is usually followed by an answer. So in a way, an answer is the completion to a question. But more so, these models have been also then, further trained using this sort of like human feedback reinforcement learning to act more like helpful assistants. And here, I'm not going to go into details on which models to use for which tasks. But generally speaking, you can kind of think of it as like models when they're at the raw form, for example, GPT-3, are incredibly versatile and powerful, but it takes more effort to actually get them to do the things you want. Whereas these sort of instruct-to models, like for example the chat models, you can literally ask them in a very simple, human question, and they will usually give you a useful answer. But that answer may or may not be as easy to then integrate into your application, in your UI, what we're talking about in a bit. So the question is, are large language models just versatile completing machines? Like, what is it we could actually do with them? Like, what are these emerging qualities that they have? And more importantly, like, what are the qualities? Are large language models, are they creative? Are they factual? Are they accurate, reliable? Are they able to reason like a human? Well, the answer to all of these questions is like, not really. Maybe. I think, there is going to be a lot of diverging opinions on this, but fundamentally what we found, playing and using these tools is that they are really best at when you collaborate with them as a human, that there's a sort of two-way discourse. It requires us as people to sort of, provide really the creativity in it. The model itself can, give you an answer, but it's you, the human, spark the reaction to it, the thing that it triggers in your deep neural network, that's where the creativity is born. Similarly, are they factual? Well, they know a lot more than you and I do factually, but they're not always correct. So like, again, it requires a human interaction there to sort of like vet validate this information. And so forth and so forth. And the question, are they able to reason? I think we'll leave that to the end if we have time, but I think that's one of the more important questions that we can talk about maybe at the speaker lounge tomorrow. But what I want to ask is, what does it mean to collaborate with such a machine? That's the title of my talk, human AI or human-machine collaboration. Is collaboration even the word? Like, are we using them as tools? Are we working on something together? What is the relationship, and what is the actual mode in which we sort of interface with one of these things? And now we get to the meaty part of the talk. Let's talk about UI. So what we've sort of discovered is that there are some sort of modes of collaboration that tend to work better than others. And again, I'm inviting you to think about whatever app you're working on or whatever app you dream about building, how these things would sort of transfer to the domain where you are in. ChatGPT, again, we've seen this all a million times, but chat is an interesting mode of collaboration because it's essentially a conversation between a human and a machine. And a conversation is collaboration, right? Like when you are at work, you have a meeting, and that meeting is collaboration. You are collaborating on something. But talking to ChatGPT is kind of like going to a meeting with a person that doesn't know what the meeting is about and isn't really prepared for it anyway, which also happens a lot in real workplace. But it's something where like you can actually iterate very, very effectively with back and forth, say, not quite like that, can be more like this. And this is super useful, but if you're working on something like a longer running project or maybe a document or a book in our case, it gets very tiresome to always have to tell that person everything about it. When I say person, I actually don't mean that the AI is a person. That was a slip. What's more interesting is when you kind of start to build the same functionality in the context of the work where you are in. So here, for example, we see that we are working on a manuscript, working on a text, and I can essentially just ask it a thing. I forget what I asked. Let's let the GIF play. Here, I'm asking, what is her response? Now, who is she? What is she responding to? In this case, she's responding to something. Her husband is in a coma, or has just, risen from a coma. But we don't actually need to tell the machine everything because we as software engineers have essentially built that context in a way, or like sent that context to the model, so it is aware of the relationships of these characters, the styles in which they speak, et cetera, et cetera. And so this is incredibly powerful because when we look at collaborating with something or someone, you essentially expect them to already know what you're working on together. So this is the kind of first step, is building, bringing this functionality in context. Here we're using this sort of slash menu thing, Notion style, but that could really be any UI paradigm. I'm not talking about it needing to be literally in the text. It's just as long as it's relevant to the thing that you're working on. The second thing is that you don't actually need to always be asking for new things. You can also ask the model to do tasks. So in this case, for example, we take text that we've already written. We don't actually want to make the effort of refactoring that text, so to speak. So we can just ask the model to do it for us. And again, this is powerful because not only does it not require us to switch to a different tab, do something else, bring it back, but it also is aware of all of that context and everything that it needs to know about the task at hand. But where we really get into the interesting territory, and this is something that I think is a little underexplored and will be explored a lot more in the next years, is in a collaboration setting, if you only have to always have to tell the other human being in a human collaboration session, or in this case the AI, to do something, that's really frustrating. That you almost have an intern at that point. You don't have a collaborator. It's just like a thing that can do chores for you. But what we want is collaboration where there's like a bidirectional collaboration. And here, can I play that again, actually? Can I? Oh, but now we need to watch it. OK, here we go. So here, this is not maybe the best example, but here we essentially write a piece of text. And then, in the background, we have a process. This sort of like agentive AI is sort of reading everything that you're writing, and then is able to provide sort of meaningful feedback and suggestions, to what you're working on. And we'll get into this more in a bit. But so now you've seen, a few of the broad modes of collaboration. But in order to sort of make these feel collaborative between the human and the machine, I think we've identified some really interesting principles, like basic UX principles that generally make this feel more collaborative, more fluid, and more successful. And I think these are the bits that will be more applicable to more domains than just writing. So firstly, we already talked about inflow. So we talked about bringing the sort of bringing the task into flow. But this is especially in the light of previous talk, being respectful of, for example, people with ADHD, not forcing a distraction, but making sure that the person can actually be focusing on the task that they want. I mean, this is number one. Second thing that's really important is to make these things fast. So one of the qualities of these models is that they aren't actually very fast in the same way as a database query is fast or a math operation is fast. They take anywhere between 3 and 30 seconds, depending on the hardware that you're running on, or the model that you're running on, or how long an output that you want. But what most of these models are able to do is, because they only predict the next word by word by word, is that you can actually get the response token by token, and that means that you can then insert that response to the user interface as it's arriving. And this is super powerful because it then allows the sort of person reading it on the other side of the screen to already be sort of reading it and making decisions whether or not to use it or what to do with it. The other thing we've already talked about is context awareness. Again, I'm kind of repeating myself here, but this is so important and informs a lot of the sort of engineering design that actually goes into building these systems. Making sure that the model and the prompt that you construct for that model actually contains all of the information that the model needs in order to make sure that the response is as coherent with the user's expectation of what they're working on. But no matter how coherent you make it, they can't always be perfect. So one thing that we found is making these things rerunnable. So sometimes these things misfire. They don't always give you the best answer. So what you can do is essentially just make it really, really easy for the user to go, no, not like that. Let's do it again. So here we have the rerun button to do that. Then the other case of this is where something is really, really good, but it's not quite there. And again, to respect the user's attention and to make sure that they stay in flow, instead of making them sort of read and ingest all of that text or code or whatever they're working on, you can also then make these things tweakable by saying, OK, so that was really good, but I want to adjust it slightly like this. And I will talk a little bit more about this in a little bit. The other thing that we found is that every time you're working on something that the user, the human themselves, created, I think it's very important to make the thing that you're about to do to it, to change it, reviewable before you do. There's a lot of psychological distress with like a machine or a black box, essentially taking something that you worked on and then, you know, rewriting it, replacing it. You know, that just doesn't feel good. And what we found, you know, doing user interviews is that, you know, giving people the sense of control and that time to build that trust. And maybe one day, you know, your software or these models will be so good that you don't actually need this anymore. But for now, I think that's super important. And even when you give people the ability to review something, you know, making it undoable is super important. Because, you know, as soon as you've committed to something, if you can't take it back, that again is like really easy way to break that trust between the human and the AI, and again, like that diminishes the sense of collaborativeness in that process. And just generally speaking, you know, making this thing non-destructive. I'm not talking about, you know, making AI that is not destructive to humanity. Also, that would be great, you know, for other reasons. But what I mean is that, you know, every time that you're working with a shared surface of something, whether it's text or it could be even a form, it could be an infinite canvas, it could be a graphic, it could be an AutoCAD, whatever you're working on, is to make sure that, you know, the AI, it doesn't have unlimited control to go ahead and delete the whole thing, for example. So, you know, these are some of the high-level principles. But the most important thing that, you know, what we found, and this is a super powerful thing where I think this could be applied to huge categories of software, even regular business software, is to start thinking more about the interaction between the human and the machine as something where we can use the uniquely human tool of natural language input in order to perform tasks. So even if your sort of general output, you know, the things that you're working on may not be initially AI created, but, you know, as a UI designers, we intuitively as programmers, we think of things in terms of buttons and knobs and maybe sliders. But here I'm asking, can you make this text less romantic? How would I express this in a traditional UI? Would I have like a romanticness slider? But then also I want to make it, I don't know, like less scary, then I have a scary slider. And suddenly this like combinatorial explosion of UI features sort of like gets very, very, you know, confusing. But what these natural language interfaces are able to do when we're operating on especially text, but also things like images, anything that isn't like structured data that has like sort of like very specific business meeting. You probably wouldn't do this in I don't know, financial planning software. I think that would be slightly weird. But you know, this enables the user to sort of like figure out what they want to do and do it without you as a developer having to actually specifically think about what exactly are the use cases. But what is super powerful is that when you then, you know, you probably track these in analytics and you start sort of grouping these things, you can also use machine learning and LLMs to sort of like group and find themes in it. You can then find out that these are the common user tasks, these are the desire lines that our users are leaving in the application's sort of logs to, you know, this is what they want. And this is actually a great way of discovering requirements. So we did this a whole bunch. You know, we added a shorten and a lengthen button because a lot of people wanted to make things shorter and longer. You know, we didn't add a more romantic button. That didn't, you know, end up on the top 10 list of things. But this is, you know, thinking about it, is like giving users, giving humans more control over the way software is interacted with, no matter what the software is, by allowing them to sort of inject their wishes and desires. And this is what I mean when I say making software more human using these tools, or humane, is that this is actually super powerful, and I think we'll start to see a lot more of this type of user interface in the future, I hope at least. But every coin has a flip side, so to speak. The downside of this is that natural language output, you know, the text that you put in, then, you know, in our case, or whatever it is, it would be your case, is incredibly flexible and powerful and intuitive. But it also has problems. It's not, you know, it's not structured data in the same way as we programmers are used to dealing with structured data. You could also imagine this in the case like a Figma or infinite canvas drawing software. Like again, like you have, you know, this data structure that describes, you know, the shape, but the way that those things sort of like interact like logically don't always make sense. And this is where we get to the third part, the programming part of this. How do we actually go ahead as programmers and like build these systems in a way that makes sense? So I started this talk by saying that sometimes it feels that web development is like rearranging rectangles. But that's because it is. Not trying to be sort of funny or controversial about this. If you think about your web user interface, like a div is a rectangle, a span is an inline rectangle, image is a rectangle with pixels in it, video is a rectangle with moving pixels in it, input is a rectangle you can type into. Like, this is basically the structure in which user interfaces broadly have been built. And that means that they actually, our tools and the way that we sort of like think about programming data structure behind them actually map into those really, really cleanly. A lot of the code that we write, no matter what framework it might be, we take an object and we bind it, for example, into a form or into a list of things or whatever. And this is typically a very simple thing to do code-wise. Similarly for lists, you have a list of these objects, you bind them into a list of rectangles, and you're good to go. In most frameworks, in most modern JavaScript frameworks, this is what it kind of looks like. This is React code, but it wouldn't have to be. It looks pretty much the same in everything. Where we have a list of items, we map over it, and we render an item for each of them. And what these frameworks then do is that they give us the output. And what they're really good at is when the data changes, they can then declaratively and reactively update that thing in a very optimal way. And this is great because this really meshes with the sort of like programming models and requirements that we've always had. But the problem with natural language is that it doesn't really necessarily work that way. For example, in the case of a long document where a human and AI are collaborating, it's not always easy to just re-render the whole thing by putting this piece of text in there. Sometimes, for example, text can cross paragraph boundaries. It can start in one paragraph, move in another. Maybe there's rich text components inside. So it gets very, very complicated. And what we found is that we ended up writing a lot of really imperative sort of manipulation code. In our case, it wasn't DOM manipulation because we use rich text editing library, but we had to do a lot of imperative coding in order to go and then manipulate the data structures behind that library. So we started thinking, is there a framework for efficiently working with natural language interfaces? And here I wish I could do one of those things like done, and I drop a library or something, but nah. We didn't have time for that, a little busy. But if we start looking at how our app is built, so a user comes to an app, it's a standard React application. We use TipTap, rich text editor, but otherwise, it's like every React application or every Vue or Svelte application you've ever seen. That app talks to a backend, a backend for frontend. That's the BFF here, or best friend for frontend, as some people like to call it. But this is a very typical architectural pattern, and there's nothing novel here. So what do we use for this BFF? Do we use Next.js? Do we use PHP? Like, what is the thing that we do here? Well, let's look at the architecture overall. Like, what are the requirements that we have? So all of the text that the user or the AI writes eventually goes into a database. From that database, we have essentially these machine learning processes that are using various language models, both hosted and, was that a Tamagotchi? Yeah, self-hosted and sort of API language models to process the text, to understand what's going on behind it, et cetera, et cetera. That process puts these sort of inferences or these findings, this context, for example, what is the relationship between Andreas and Carolina, into a semantic search database. This could be anything. We use a product called Pinecone, but it could be, there are dozens, soon to be hundreds of semantic search databases. And then from there, we can feed these sort of agentive processes that are able to react to user changes, but are also able to proactively go and edit the document in an agentive sense, like we saw in the case of suggestions. So what is this magical BFF that we have? Again, Next.js, PHP. It's technically speaking, the way we do it is not even actually a server. It's a data structure. Specifically, it's a very particular data structure called a CRDT, or a conflict-free replicated data type. Maton will have a talk about this tomorrow. But just to give you a little sneak preview, CRDTs is this really curious type of data structure that allows multiple clients to update the same document and guarantee that the resulting document always ends up in a consistent state. But the really cool thing is that it allows you to do this in real time or asynchronously, no matter how many concurrent editors you have in the same document. And then that means that from a client perspective, you have a data structure that is always in sync, and you can just re-render that as if you would do with React, or in our case, the prose mirror text editing library. So essentially, using this algorithm, we're able to allow multiple parties to sort of work on the same document. It doesn't need to be one long text document. It could be a list. It could be a map, like an object. But the operations are always ordered and guaranteed never to conflict. We use an implementation called YJS. This is a great library. I highly recommend everybody to take a look at it. But basically what YJS provides, in addition to the core CRDT algorithm, it enables you to sync it with a server. It provides offline support. So if as a writer, for example, you want to work on a train or at a cottage in the country while growing your own vegetables, you can do that. And it also supports a peer-to-peer model where you don't necessarily even need a server. But in our case, we do want a server because we actually want these online AI processes to be able to interact with it. Not going to show a lot of code, but I've been told that if I don't show code, then people will go, why didn't you show code? So here's some code. I hope you're happy. At a very high level, you get an object. You can put anything in it, like anything that is either structured like a map or a list or a piece of text. And then when you update it, all connected clients get those updates eventually, and then you can react to it. There's also a lot of great libraries that you can use these to bind them to UIs. So we use, for example, something called Synced Store, which provides a very sort of MobX-like interface to YJS. These are incredibly cool libraries and tools and technologies, and Matan's talk will probably go more into the sort of internals tomorrow, so we don't need to go deeper into it. But if we kind of zoom back out, and we look at this YJS backend for frontend that we have. One thing that we can now do is we can provide, the AI can literally enter the chat. It can be another user in the session. We don't actually express it this way because for the reasons of reviewability, et cetera, we don't actually want the AI to go and start just randomly typing into your document. That would be very distressing. But it's, this is possible. But one thing that also comes out of this when you start looking at this is that actually, this is no longer collaboration between just human and an AI. We've just created a system that allows arbitrary collaborators, arbitrary AI models, but also arbitrary humans to collaborate on the same document. And so this is kind of interesting. When we start thinking about the idea of collaborating between a human and an AI, we've accidentally created a system that allows also humans more effectively to collaborate with each other. And this is what I mean when I say that I want software to be more human and more humane. I think the dream has always been for technology to sort of connect us more. And connecting us to the AI can feel, like we are, in a way, talking to all of human knowledge, but it's intermediated by the machine. But I think when we can sort of bring people together, in addition to bringing the people and the machines together, I think we can build really, really interesting software. So when we start thinking about the second question that I asked, which was, what can we build now that we couldn't build before? We don't need AI for this, but we also happen to have a lot of new infrastructure coming out. Cloudflare's Workers, for example, and Durable Objects platform, things like PartyKit or Replicache, enable you to build these sort of systems that are real-time, that are collaborative, and AI kind of just slots in there in a really, really nice way, where if you architect your application in this way, you can create systems that are sort of more human, just for humans. So I think I'm 3 minutes over time. I think we don't have a lot of time to talk about the whole are machines able to reason thing, but we can have a conversation about that tomorrow on the first coffee break when I'll be at the alternative stage. But I do want to leave you with something. Which is that, the question, what will I do when the AI has made programming obsolete and, et cetera, et cetera. I mean, I don't think that is necessarily going to happen. I think, for us, we should all expect the nature of our jobs to change. I think the way that we write code, the way that we write programs will change. But this also enables us to sort of start thinking about new ways of building software and ways of building new software that doesn't exist before. So I do highly recommend everybody to sort of like start thinking about that and sort of like participating not only in the conversation, but also participating in the process of discovering these things, as we've done here with this experiment. Figure out, experiment. And when you do, I think it's also good to remember that AI, we talk a lot about the risks and the harms. I'm, being moderately optimistic here about that it also can help. But we as engineers now have more so than ever, we're asked to make judgments about what is right and what is wrong. Like how are these systems built in a way that is actually aligned with human interest? One example of this is in practice, we get asked all the time is, hey, can we have a little thing where I can just write my favorite author's name so it can write in the style of my favorite author? And this is the most requested feature by far, and we are never going to do this, mainly because we don't believe that that is the right thing to do. These authors whose information was fed into it, they did not get the credit, the compensation, or they didn't give their consent to participate in this. But we also don't think that it's okay for us to bury our heads in sand and say, oh, because there are these really valid moral, ethical dilemmas involved in this, it's not, I think, possible to bury our head in the sand and say, well, we will just, as a humanity, won't use these tools, because these tools will get used no matter what. So I think it's a question for us to sort of like participate constructively in this, and like when we are decision makers or when we are the people who are asked to build these things, to actually, ask ourselves what is the right thing to do, and then do that. I think that's the only ask I have for you. But I am over time. Let's talk more tomorrow. Thank you.